All right, welcome back. So far, we've got the joystick reading properly. We've tested to make sure it's working. So let's move on to the next thing. If I click back over to my ROV notebook, I can see our next thing is to map the RJY value from 0,023 to 180 and store it in those three angles. So let's get to that. So the first thing I'm going to do is come over. I'm actually going to close out this screen so there's not this craziness over here. We're going to do a map function, and we're going to map the RJY. That's where, whoops, see, I made that typing mistake here. I'm going to actually double click this, Control C, and put it there. We're going to map RJY. The reason we're doing that is that's where the value is stored from the joystick. And we're going to tell it the next two numbers to put in is the starting range of the data in RJY. What's the smallest and biggest it can be? Well, that range is 0, 1023. And then we need to do the range that we're mapping it to. So we're taking this large range of 0 to 1023 and mapping it to a smaller range of 0 to 180. So we're going to go 0, 180, and then a semicolon at the end. And just like up here with the analog read, the Arduino will happily do this and then instantly forget the new number. So we need to put this number somewhere, and we're going to put this number into our angle values for each of the servos. So I'm going to L servo angle is the name of my variable, and I'm going to go equal and space L servo angle. Yep. So now what it's going to do, it's going to take the joystick data from up here. So we read the joystick data here. We stored it in the variable called RJY. We took that number, say 412, and it's going to say, okay, I'm going to map it from this range down to this range. So it's going to change that 412 into something like 83 or whatever that angle is mapped to down here. Piece of cake? All right. Next thing we're going to do is we need to do this. Let's put a comment here before we copy and paste stuff. So this converts the, oh wow, I'm having a hard time. The joystick into servo motor values. All right, next thing I'm going to do, that's joystick. Okay, I'm going to copy. So what I did here to do this fast, watch this. I'm going to try this on your own as well. Click on the number 23 so you can see the whole line is selected. Do Control C. Don't click on anything else. Stay right there. Do Control V. It looks like nothing happened, but what it really did is it pasted that same thing on top of itself, and then do Control V again, and it puts it below and again. So with just a few Control V's, you can really fast create more lines of data for yourself. So we've got 3 servos, so we're going to map it 3 times. We're going to send this one we're going to have this one in left, right, and front. And notice every time I do something, I always do left, right, front. Up here in the pinout, left, right, front. All of these I'm going to do that same thing with. Now, I've gotten a little ahead of myself. I've used a variable, but I haven't created that variable yet. So I'm going to come up here where it says RJY. I'm going to keep all my pins together in one chunk and my values in another. So I'm not going to put it with the pin. I'm going to put it with the JY val down here. I'm going to do INT and Control V. Whoa, that was too much. Let me double click on left servo angle, Control C, Control V. I'm going to give this a starting value. Well, my starting value needs to be in the middle because that's level. So I'm going to give it a starting value of 90. This is a good example of having a starting value that's not 0. 0 in this case would be facing straight down, and it would be weird for it to go straight down and then get adjusted back up. So we're going to start out at level. And I'm going to click on 14 again, do Control C, Control V, and then 2 more V's, Control V's, and change this one to R and F. So again, L, R, F. If you're consistent in your pattern, you'll find mistakes more easily because you'll see changes in the pattern. If you're chaotic in how you do things, it makes seeing patterns and mistakes harder. Okay, so everything looks good so far. Let's go back and check. We just mapped RJY and we stored that value in all 3 of those variables. Awesome. So now we're on to this part. Now we have to ask ourselves, if the servo angle is greater than 180, we need to set it back to 180. So let's build that code. So I'm going to come down below here and add a few more lines. I also like keeping this bottom one away from what I'm doing so I don't accidentally delete it or to mess with it or anything. Come back up here, and I'm going to ask the question, if the, let's choose one to start with. I'm going to click this, Control C, Control V. If the left servo angle is greater than 180, so that's my first part. And normally I would put a semicolon here to end the line, but this is an if statement. I don't want to end the if, I want to open the if. So I'm going to use a curly bracket here, an opening curly bracket. And when I push enter, you'll see that the Arduino IDE automatically puts a closing bracket for me right here. So these two pair up with each other. Anything between these two brackets, all the commands inside here, are going to be run whenever this top thing is true. If this isn't true, if it's not greater than 180, if it's less than 180, it's going to skip the stuff inside here and do whatever's next in the code. All right, so if it's greater than 180, we need to set it back to 180. So all we're going to do is double click on the name of our variable, paste it down here, and just say equal to 180. So if it's like 182, it's going to come down here and set it back to 180. So now our variable can never be outside, be greater than 180, because that's just going to control that. Now we also need to go back to our notebook here real quick, and we say, okay, so that's this part here with the true part goes inside the if. The false part of it goes below the if. So it's the next thing in the code is where it is on the false side of the flow chart. We're going to do an else if the servo angle is less than 0. We need to set it back to 0. So I'm going to come down here and say, okay, right here, I can do the else if right here. This is a fine way of doing it. Else if. And then I'm going to say the L servo angle is less than 0. So here I was asking, is it greater than 180? If yes, set it to 180. If not, check to see if it's less than 0, if the servo angle is less than 0. So again, I'm not going to use a semicolon because I don't want to end the line. I want to open the else if, and then press enter. It'll add another one in for me. I'm going to do this same thing, except I want it to be equal to 0. So if it's a negative number, it's less than 0, negative number, it'll set it back to 0 so we don't accidentally send our servo motor something it can't handle. All right, beautiful. Now this is one way to format it. The way that you typically see, though, is we don't put the else if down below like this. We put it after this closing bracket. What that does, it makes this all look like a tighter bunch, so you can see that it's really one thing. It's an if, else if statement. These two things are linked together. So the reason it's linked is this. If the servo angle is greater than 180, it's going to run this code and set the servo angle back to 180. Then it's going to skip this else if and not waste its time, because we know if it's greater than 180, it's definitely not less than 0. So we can just skip this other code. If instead we had done it this way and we hadn't used the word else, we just put two if statements, it would check every servo angle to see if it's greater than 180. If it was greater than 180, it would set it back to 180. But then it would stupidly check to see if it's less than 0, which we know can't be true. So in this case, using an else if is a better approach. All right, now that was the if else for the L servo. We need one. Oh, let's put the comments in before we start copying and pasting. Otherwise, we'll be commenting out all over the place. So this sets the angle back to 180 if it is ever higher. Than 180. Good. And this one, whoa, I don't know what I typed. Sets the angle back to 0 if it is ever negative. All right. So that controls the L servo. It keeps it from going over and above. We need to do the same thing for the R and the F. So to do that, I'm going to click on the 30 and drag down until I get down to line 35. That has the whole thing highlighted in gray. I'm going to go Control C, Control V, V, V. I'm actually going to put a line in between these so I can kind of see that they're different if statements. And I'm going to change all of these L's to R, and this one to R, and R, and R. So that one just fixed, make sure the R's are never too high or too low, and then F. So just like that, we've gone through and tested all three of our variables to make sure they're not too high and not too low. Oof, that was a lot of work. All right, let's check back and see where we are. So we've read the joystick, we've mapped it to all three variables, we've checked to make sure those variables aren't too high or too low, and if they were, we've changed them back to the correct number. Now we need to use the 3 servo right commands to send the servo angle to each servo. So now we need to actually tell the servos to spin to that angle. Before we do that, let's check to see how we're doing. We should have done this before the if statements actually. Let's come up here and do some serial writes. So I'm going to do serial prints. Serial.print, and I'm going to print for the L servo angle. I'm going to do LSA, except in quotation marks, sorry, LSA space equals space, semicolon, and I'm going to do another serial print on the same line, dot print, and I'm going to do RSA. Nope, sorry, I want the variable. So I'm going to come up here, double click on my left servo angle. Yikes. Control C, Control V, semicolon. So this checks to see if mapping worked. So if the mapping worked, I should be getting things like 0 to 180 and not 0 to 1023. I'm going to copy and paste this, Control C, Control V, V, V. I'm going to put a couple blank spaces between these so they're spaced out because it'll be next to all of these things. I'm going to change this one to R and this one to F, and this one to R and this one to F. And I want to add an L in lowercase f. I'm going to add an L in right here at this last one, so that after printing all 6 of these in the same row, it'll jump down to the next new row and print all of them again. Okay, so let's do it. Let's load it. So I'm going to send it to the Arduino. I'm going to open up my monitor, and we'll have to wait for it to start kicking in. Awesome. Now it's a little bit garbled, but it's also too small for it. So I'm going to bring it over a little bit. And you can see sometimes it gets really garbled on my end. So what I'm going to do though is I'm going to start rotating. It should be around the 90s right now. When I rotate it up, they should change to the 180s. Oop, and they all do. And as I go down, they should change to 0. And they all do. It's really hard to see. There's something wrong with my serial monitor. Hopefully yours is clean and smooth. Awesome. So that part's working. So what I'm going to do is I'm actually going to close, because this drives me nuts to see these things scrolling on the side. I'm going to close that back out. I'm going to click on 29 and click on line 29, drag down to 31. Hold down Control and hit slash. That'll comment those out. So if I need them later, I can get them. I don't want to delete them. But for now, I don't have to worry about having them on the screen. And now I'm going to do this. I'm going to copy and paste. I'm going to grab these 3, Control C. I'm going to put them below here. Because what we've done is we've mapped those values into these 3 variables. We checked to make sure they were working. They were. And now we've done something to them. So we've made sure that they haven't exceeded their values. And we're going to print them again afterwards to make sure that that part's working as well. Now we don't actually ever get a value more than 180, so this part isn't doing anything yet. In the future, it'll do some stuff, and we can easily uncomment these three and check to see if it's actually working. So that's why I put them there now. All right, last step. I promise, we're close, sorry. We're gonna need to actually send the commands. The command is pretty straightforward. The thrusters use a command called write microseconds, but for this one, oh, we haven't added our servos yet. Oh, we have several things to do. So, this command is straightforward. Let's get it on though. We need to have the servo library added. Yeah, we can do it in this thing. It'll be quick. So to do that, we're going to do hashtag include and space and then a caret, like a little pointy parenthesis, and then servo with capital S dot H, close caret. That will add the library called servo.h to our sketch, which means we can use all the servo commands now. Yes, that looks great. Next thing we need to do is we need to name our servos. So to name the servos, we're going to do it up here under the include. We're going to do capital S servo, and then put a space in, and then the name of your servo. I'm going to name mine L servo, semicolon, and then again, I'm going to just copy and paste this. Control C, V, 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 and change the L to R and the L to F. So I just created 3 servos. The first one called L servo, the next one called R, and the next one called F servo. All right. Now we need to go to the void setup. This is where we're going to put where we've attached our servos. So I'm going to come down here and hit enter, and I'm going to say name of the servo. So I'm going to double click the L servo. Oh, let's actually put a comment up here. So this creates a servo, creates and names a servo motor. And because I didn't do this before I copy and paste it, I need to do Control C and copy and paste this down here. All right, so now down here in the void setup, back to this, I type in the name of my servo, dot, attach, and parentheses. If you spelled it all right, the attach will turn orange. And then I need to tell it where I attach to. Again, I don't want to put in the actual value. I think here left servo is in 5. I want to create a variable for this purpose. So I'm going to come up here to my pin variables. I'm going to type in int, and I'm going to say this is the L servo pin. And it's going to be equal to 5 semicolon. So I'm going to click here and get Control Z, V, and V, and V, L, change the L to R, and to F, except lowercase r, whoops. And now I can use these down in my code. So instead of putting the number here and having to find it later, I have it right up here with all my pin numbers. And that's why I always put the pins at the very top. So if I do need to change something in my wiring, I can very easily find out where to go. Except this should be 5, this one should be 9, and this one should be 11. Perfect. All right, now I'm going to come down here and I'm going to say, hey, this line of code tells the Arduino which pin the servo motor is plugged into. That's plugged into, it's French. It's not French. All right, so I'm going to do this exact same thing. Oop, I forgot my semicolon. Hopefully you guys noticed that. I'm going to copy and paste, and then change the L to R, change this L to R, L to F, L to F. All right, so we named our servos. We told the Arduino where we attached them at, where they're plugged in at. And now I'm going to come down here. I can send the command. So here's the command. It is the name of the servo. So I'm going to come up here and grab that real quick so I don't have any typo errors. And I'm going to do dot, and I'm going to do write, parentheses. It's a lowercase w. And so the thrusters need a right microseconds. The servos just need a simple right. And what am I going to feed the L servo? I got to think, well, where am I storing the angle for the L servo? And it's okay, yeah, I'm storing it in this thing called L servo angle. So I'm going to double click on one of these. Any of them is fine. Copy that one and put it in here. And then hit a semicolon. Add a comment, and so this sends the angle data to the servo motor. All right. I'm gonna do the auto indent real quick. It's gonna take a second to do that. Oh, it's getting into a long video. Sorry. We're almost there. We've got like 2 lines of code left. I probably shouldn't have done this. It was bugging me that it wasn't quite in the right line up here. Oops. Okay, it just lined up everything nicely. So what I'm going to do is I'm going to highlight, click on 65 here, whatever line you're on. Don't try to be in the same line as me. That's crazy. Control C, Control V, 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 and I'm going to change the L to R. You probably know what I'm going to do next. This L to R, this F, and this F. All right. At this point, you're ready to fire up this code and see how it's working. I'm going to do a quick verify and save just to look for any last minute errors, see if I made any mistakes in here. Okay, mine came up clean. If yours came up with errors, fix those errors. If something doesn't seem right, let me know. The next thing to do is to set it up on your ROV. This is going to rotate all of these servo motors to level, to 90 degrees. So before you do this, because your servo motors may be all the way backwards or really messed up, it's going to rotate them all the way around. Remove your thrusters from the servo motor. Leave, I can't bring it over here. Maybe you can see it. Leave all of the connectors attached. You can take out the center screw and all because you're going to be adjusting them in a second, but leave them attached, but take your thrusters off. Because if this rotates a ton all the way around, it's going to end up like tearing these lines and breaking things because these servo motors are really, really strong. Okay. So that's what's next for you. You're going to attach a battery to the battery plug. That'll power up the servos and run this code, see what happens. Best of luck to you. Follow along in the program, in the notebook.